Okay, so we're talking absolute value equations, solving absolute value equations. So what is an absolute value? It's a number's distance from zero. If we look on the number line at numbers like -3, for instance, that absolute value will be 3 because that's how far away it is from zero, just in the negatives. Absolute value of 0 is actually 0. Its distance from 0 is 0. That's the only one that's kind of weird like that, because 0 is not positive or negative. Anyways, let's focus more on the positives and negatives. +5, absolute value of that is going to equal 5. So it's not that the sign switches always, it's just that we take the positive number. We can see that in words down at the bottom. Positive or negative number inside the absolute value is going to equal that same number, just positive. Okay. So what is in the absolute value can be either negative or positive. Let's think about that. Whether it's -3 or +3, it's going to come out to equal 3, either way. So when we start to solve equations, when we have the variable, we need to think about that. There are two answers, either the -3 or the +3. So when we see it like this, where there's a variable or even an expression with a variable inside the absolute value, we're going to split it into two separate equations. We call those opposite equations. One with a negative and one with a positive over here. That's negative and that's positive. Okay. So our first example, straightforward, absolute value of x equals 10. Let's create the opposite equations. X equals -10 or x equals +10. We've got those two versions, the negative and the positive. Let's check it out. Make sure it works. Okay. We put the -10 inside the absolute value, and yeah, it turns to a +10 down here, and that does equal 10, so we know it works. It checks out. Next, we plug in the +10. Same thing. Absolute value of +10 is a +10. This works. Now it's a little bit trickier. We have an expression inside the absolute value, but we do the same first step. Create or write opposite equations. We no longer have the absolute value symbols. They're gone. But x minus 4, that expression, equals either a +6 right here or a -6 right here. In both situations, we're going to solve. We're going to solve by adding 4 to both sides of both equations. Fun stuff. So on the left, we're going to get a 10. X equals 10. On the right, since we had this -6 and a +4, different signs, subtract, keep the sign of the larger number. That's a negative. So x equals -2. It looks a little weird if you're not really sure about why that works. Fear not. We're doing a check right now. Let's check it out. So x equals 10. We plug that back in, not to any equation, but the original equation up top. Really important. So 10 goes in for x. 10 minus 4 is 6. Okay. So yeah, 6 equals 6. A little bit trickier with the negatives coming up. We plug in the -2. -2 minus 4. That will be a -6. They're both negative, so we add and keep that negative sign. So now we have a -6 in the absolute value, and that is going to turn to a +6. This also works. Notice that we have two answers. One that creates a positive in the absolute value. That's an arrow. Wonderful. And one x value that creates a negative inside the absolute value. Either way, we get a +6. Awesomeness. Example 3 looks a little bit different because this time on the left side, we have not only the absolute value sign, we have a number outside of the absolute value. So we're not going to start by creating opposite equations. We're going to start by isolating the absolute value. We need to move that 5 from the left side to the right side. We can do that by subtracting 5 from both sides. That's the only way to get rid of it on the left and get that x in the absolute value all by itself. That's what we want to see. Now, finally, we can create or write opposite equations. We've got x equals 3 or x equals negative 3. Let's see if this works. And the first one does. We plug in a positive 3 into that absolute value. And sure, that's just positive 3. Plus 5 is 8. Yes, check. We put a check. Woohoo. We did it. Let's check the second one. Now with the negative, basically the same thing. First step in the check here is that negative 3 turns back to a positive 3. Absolute value. 5 plus 3 is 8. And check mark. Sweet. Example 4. So we have the absolute value all by itself. Okay, so immediately we are able to, wait a second here. Do we create or write opposite equations? No, we do not. No, we do not create opposite equations. Why? Why? It's all about this negative number. Okay, negative 7. This is just not possible. There's no solution because an absolute value cannot equal a negative number. There's no way we can have any value of x that's going to add to 3 and come out of this absolute value as a negative number. Not sure? Don't believe me? Well, let's check. So maybe we try 4. Yeah, 4 plus 3 is 7, but absolute value of 7 is a positive 7 on the left. We're not getting a negative 7 that we wanted on the right. Okay, what about creating a negative inside that absolute value, like negative 10? Let's plug that in, add it to the 3, adding integers with different signs, subtract the numbers to keep the bigger sign. So, oh, cool, we've got a negative 7 there, but again, this is the absolute value, so it's going to come out of that absolute value sign as a positive, no matter what. That's a plus sign I'm creating right there. Yeah, so there's just no way that we can get a negative number out of that absolute value. The moment you see not just the negative here, but specifically an absolute value equal to a negative, that's when we know that it's no solution. The absolute value has been isolated all by itself on one side, and it's equal to a negative. I don't think so. No solution. Good day. An absolute value cannot equal a negative number.